As we begin our Unit 5 with imaginary numbers, the thought process is that any problem that we have well, I guess if we look closely at the degree of each polynomial, and we've been working with quadratics so far, you're supposed to have that many solutions. So because this is degree 2, then you're supposed to have 2 solutions. But if we think about it, if we look at this problem, y equals x squared is actually drawn right here. I'll go ahead and show that. If we look at x squared plus 1, that is shifted up 1. And so I can just draw that real quick right here. Basically looks like the same curve, except it doesn't cross the x-axis. And I'm saying that because, alright, so that's f of x. That's doing letter B. The reason why it's important is because the x-intercepts are the solutions. There are no x-intercepts. In other words, there is no, I may use it, this might be a new term for you, real solutions. Real in the sense that you could see it. But imagine for a second, hence our phrase imaginary, is if we were to try to solve this, what we would do is subtract 1 to the right side, and 0 minus 1 is negative 1. And the thought process is, well, what if we try to square root a negative? Well, let's create a new number system, hence the imaginary number system, in which case we can square root a negative number. And the thought process is, and yes, this is supposed to be an italicized I, so when you see me write it, I'm going to write the answer as positive and negative, this I symbol, and I put a little hook on my I. I think there's a name for it, but I can't really imagine. And you can see that you do get 2 answers, the positive and negative version of that. But as far as the real numbers goes, anytime you have an imaginary solution, I'm going to write the word implies, there's no x-intercepts. So you can visualize what's happening anytime you have an imaginary solution is you're finding something that works for the equation, except it's not a real number because you can't visualize it. There's no, you have to imagine, so to speak, that it's crossing the x-axis. So here's the thought process, is if we try to do a few of these problems, remember the reason why we cannot square root a negative is because the thought process is, I'll just do 3 for a second, that 3 times 3 equals 9. So it makes sense that the square root of 9 is 3, but also negative 3 times negative 3 gives you a positive 9. So that's why we can never square root a negative in previous lessons, because a negative times a negative is positive. Well, we fix that by essentially rewriting this problem. I'm going to over-explain this first one as the square root of negative 1 times 9. And so we can rewrite it as the square root of negative 1 times the square root of 9. And the square root of negative 1 by definition is I. We typically write it over here. And then the square root of 9 is 3. So you can quickly do a lot of these problems. If you haven't memorized that the square root of 100 is 10, and then because of the negative inside of there, put in I, 10I. So practice your rules that we've talked about before of simplest radical form still, where you can pull your 4's in front. Any pairs of numbers, circle it in red because I haven't used that color yet. So it's going to be 4. I like to put the I in front. And the reason why I like to put the I in front is because you might have a teacher be mad at you if you write the answer this way. This is acceptable, so this is good, but what is not good, that's a terrible writing, is if you lazily just write this. Because sticking the I under the radical is a no. You do not want to do that. Let me cross that off. That's a bad answer. So to save me from doing that, I usually stick my I in front. So you might do that as well. Same thing with the next one. Break this down. 9 times 2. You got a pair of 3's. And if you do this the way I do it, you write 3I root 2. All right, but just kind of a heads up, if you write 3 root 2 and then times I, just make sure that your radical clearly stops before you get to I. So we go through that process so we can answer a few questions like this. So these ones are, notice there is no bx term. And so when there's no bx term, you can just get the square by itself. You know, I've used the phrase isolate x squared, and that's exactly what you're going to see me do in this problem. So subtract 8 over, and you're at 5x squared is equal to negative 20. That when you divide both sides by 5, you get x squared is equal to negative 4. And when you square root, make sure you write both answers, the positive and negative version of the square root of 4 is 2. And then because it was the negative, you have to put an I in there. That's a very ugly looking eye, but I'm not very good at drawing eyes with this tablet. So do the same thing with the next one, you know. Subtract 20 over. Half of x squared is equal to 2 minus 20 is negative 18. I can solve this by multiplying the 2 over, you know, to cancel that out. So I'm back to x squared equals negative 36. And when you square root both sides, you better write down plus or minus. The square root of 36 is 6, but because you square rooted a negative, you have to do an I in there as well. So then the next one, very similar. You know, you add the 10 over, so you have 2x squared is equal to negative 26. Divide the 2 over. And if I do some poor arithmetic, feel free to call me out on it. You know, write it down, bring your question to class. But I don't know the square root of 13, so I just leave it as root 13. And it's a prime number, so you can't break it down. The next problem gets a little bit more complicated, so stick with me. But you kind of treat the i's as if it's a variable. For instance, you probably already know that you could rewrite this as 5 times 6 times I. In other words, you can rewrite this as 30I squared. Now this is where it gets tricky, because the definition of I, let me go back to red, I is equal to the square root of negative 1. So imagine for a second I asked you to square both sides, because that's what I squared is. Well, the thought process is the square root and the square cancel each other out. So I squared is equal to simply negative 1. But you still have this 30 in front, and 30 times negative 1 gives me an answer of negative 30. So option 3 is correct. And so here's sort of the thought process, is we can actually come up with a pattern for all of these. And I'm going to try and keep this clean. So I just talked about how I squared is equal to negative 1. So I cubed is equal to negative I. And let me explain why that's the case. Because you could rewrite I cubed as I squared times I. Well, remember, I just said I squared was negative 1. So negative, I can replace negative 1 in for I squared. Negative 1 times I gives me negative I. And I could explain I to the fourth very similarly, but I would explain it as I squared times I squared, right? Multiplying with the same base, you add the exponents. But I squared is negative 1. I squared is negative 1. Negative 1 times negative 1 is positive 1. So we have this pattern going on. I, negative 1, negative I, 1. If I take it to the 5th power, it's actually going to go back to I. So again, I'm trying to keep it clean, but let's think about how I to the 5th is equal to I to the 4th times I. Well, if I to the fourth is equal to 1, 1 times I gives me I. And try to figure out if these patterns are going to continue to happen. I hope it makes sense that these are going to all repeat, because I to the fourth times I squared is I to the 6. So 1 times negative 1 would give me negative 1. And yes, these patterns do repeat. And it's actually a very nice visual. Maybe I'll show you real quick. Is you can actually draw a picture sort of like this. And you'll understand as we get to later units why this value is going to be 1. And we just sort of go around in a circle. So this would be the same as like I to the 0 power is equal to 1. And so if you do I to the first power, you get up here at I. But think of this as being a number line. If you do I squared, so 2 quarter terms, we're at negative 1. And then if I do I cubed, well, because it's downwards on the imaginary axis, it's going to equal negative I. And then as I do I to the fourth power, so 4 quarter turns around, I get back to the first. So then 5 quarter turns all the way around, I get I to the fifth, which is equal to I. And then 6 quarter turns around. I hope you understand what I mean by quarter turns. I'm talking about like this is a quarter turn, and then do this as another quarter turn. And you can just repeat. So there's a little visual understanding for anyone that thinks you're a visual learner. So if you think of the problem that way, you could do several quarter turns. So in other words, I could do I to the fourth times I to the fourth times I to the fourth. Basically what I'm trying to get at is I to the 36 power is equal to several I to the fourth. So why am I choosing to the 36? Is that's the next multiple of 4 below 38. So I to the 36 is equal to 1. So 37th, 38th would correspond to this value. So it's equal to negative 1. And I can do the same thing with I to the 21st. I might just say I to the fourth times I to the fourth. I could actually write this out because there's only 4 of them. That's equal to I to the 20th. So it's 1 times 1 times 1 times 1. Hey, that's 1. But I have 1 left over, so it's got to correspond to this digit. So it's just equal to I. So just thinking out loud, I to the 80th power is equal to 1. So this must be equal to I cubed, because I have 3 more of them, which is corresponding to this one, negative I. And then kind of struggling to see what this one is. It looks like I to the 40th. So if it really is I to the 40th, double check on your page, but that's equal to exactly 1. And so you could work out some pretty difficult problems as long as you understand those rules, like I to the 16th power is equal to 1. So you're looking at 5 times 1. I to the 23rd power, well, I to the 20th is equal to 1, so this must be I to the 3rd, which is equal to negative I. And then I to the 26th power is equal to negative 1. And double check. See if what I'm saying is making sense to you. But what I see here is 5 plus negative 1 gives me 4. And then 3 times negative I is negative 3I. So this might take you a while to understand, but that's the overall theme on these imaginary problems. And we're going to expand on this in the next section. So you should be ready for your homework now.